My name, as Isha mentioned, is Luke, CTO at Pulumi currently. Previously spent time building kind of developer tools while I was at Microsoft, so building some programming languages and IDEs and that sort of thing while I was there, mostly for application developers. And then spent some time at AWS working on EC2, so on core cloud compute. And Pulumi is really this opportunity to kind of bring those two worlds together, to bring kind of some of the tools and things that we built for application developers around software engineering and scaling up the complexity of what we build with software, and bring that into sort of the cloud infrastructure space where we're seeing the complexity of what development teams and infrastructure teams are needing to manage, going up quite quickly as they move into the cloud and modernize their applications in the cloud. And so today I want to talk a little bit about modern infrastructure as code. I'm excited to be here kind of at the Melbourne DevOps Meetup. As I mentioned, just as we were getting started here, recently moved back to Melbourne after many years back in the US. And I'm so excited to be able to join this group and talk a little bit about this, and excited to sort of take some questions and talk a little bit about infrastructure as code more generally as well.
Got it? No.
All right, so with that, let me dive in. So before I talk about kind of infrastructure as code or Pulumi specifically, I thought I'd maybe talk about kind of how I think about the transition that we're seeing kind of in the cloud. And I think we talk a lot about sort of migration to the cloud and the sort of lift and shift of things from on-premises towards the cloud, and there's sort of this continued shift of workloads into the cloud that I'm sure folks here have sort of witnessed firsthand. But one of the things I think we don't talk as much about is the sort of transitions that happen once folks move into the cloud, and how application architectures have been changing in the cloud, and what these sort of modern workloads look like, and how they're fundamentally different than some of the traditional early cloud. And so I think, you kind of had, if folks here I'm sure will be familiar with sort of the way these architectures looked, we kind of had the pre-cloud and maybe very early cloud where we had a VM and it was very special, and we ran all our software in it, and we ran a bunch of scripts inside that VM and managed all the software running on that, and just ran our application, and life was easy because we just had one box. It was easy in one sense, that we just had our own box and we got to manage it, but it was hard in the other sense. Now we had all the operational responsibility around how to make sure that box stayed alive and was able to scale up, and all the challenges we know about there. Of course, V2 kind of, we brought in, Docker, we brought in some early cloud concepts like auto scaling and the ability to sort of scale up. We still dominantly kind of manage the software inside our VMs and thought in sort of a VM-centric way about kind of how we organized our software to exist, where we ran our database, how we managed the lifecycle of that sort of thing. I think the sort of this V3, or kind of what I talked about as sort of the modern cloud piece, is really where we start to take advantage of more and more of these managed services, right? And so all these cloud providers are providing these amazing building blocks that allow us to sort of hand off operational responsibility to cloud providers. And so as part of doing that, we hand off that responsibility. And I think a lot of people look at this chart, look at this picture, and they're like, oh, that thing on the right looks way more complex, right? And, why would I want that thing? And the one big benefit of the thing on the right is that the sort of gray boxes, which are sort of the pieces of code that you own, the thing you're responsible for operationally, those have gotten a lot smaller, right? You've handed off a lot of the operational ownership to your cloud provider. They've enabled you to have these amazingly rich managed services that you get to work with and interface with. And your ownership has moved down into just these little gray boxes, the containers you want to deploy into Kubernetes, or the Lambda code you want to deploy into Lambda. But there's one place that the complexity has gone up, right? Which is all these arrows, all the ways that you connect all the different pieces of the infrastructure, what managed services you're using, how they connect to other managed services, what relation, what IAM privileges they have, or what networking configuration they have. All these sorts of things become now where the complexity has moved. So you got to get rid of a lot of operational complexity, but you had to buy into, well, how do I stitch together all these managed services that I'm going to use? And that's sort of exactly why I think infrastructure as code has become so much more important now, because now the place where the complexity has moved is, how do I manage all this cloud stuff I've got? As I move towards these architectures, I've got so much more cloud infrastructure. It's moving so much more quickly. It's changing every day instead of every month, perhaps. And so now I need to that becomes something I need to manage with infrastructure as code and manage that complexity. So that sort of sets up why I think of this as being important. Now, folks may say, hey, infrastructure as code, kind of, I know about that. That's CloudFormation, that's Terraform, that's Azure Resource Manager. I've sort of done these things in the cloud. And one of the things, and that's true, and those, great tools, very important. One of the things that we've seen is that a lot of those tools, even, infrastructure is code tools, but they're sort of infrastructure as text tools, right? So the core thing that they provide is that they offer you text, so you can source control that. You can write down in text what the desired state of your infrastructure is. But one of the things that we sort of think about when we think about infrastructure as code is, what about all the rest of sort of the software engineering capabilities that you think about when you think about code, right? So what about testing? What about versioning? What about package management? What about sort of the productivity of having an IDE? What about all that shifting left of sort of the developer experience so that I can productively kind of develop on things? And so when we think about infrastructure as code, what we really think about is, how do we bring all of those sort of software engineering capabilities from application development, from code, that we know have helped teams to build the incredibly complex applications that they're delivering today, instead of having to write everything in assembly code like they did 30, 40 years ago. How can we bring all of those same sort of the abstractions, the tools, all those sorts of things into the cloud infrastructure space? Because we are seeing and are going to continue to see that same increase in complexity in the cloud infrastructure side. And so that's sort of where kind of Pulumi in particular comes in, and obviously there's other tools in this space, but I obviously, being working at Pulumi right now, we'll kind of talk about it through the lens of Pulumi, but a lot of this applies generally, I think, to kind of where infrastructure as code, we see going, and some of the interesting opportunities and challenges that we're facing kind of as we scale up complexity of infrastructure. And so Pulumi is sort of a modern infrastructure as code tool designed for both this world of embracing kind of the software engineering capabilities, embracing this complexity that we need, but also focused on sort of the modern workloads that we see in the cloud. So focused not only on VMs and oops, I'll get rid of that. Not focused only on VMs and networking and that kind of thing, but also on containers and serverless and Kubernetes and the kind of patterns that we see, and serviceful workloads, the kind of patterns that we see kind of in modern infrastructure. Pulumi targets any cloud and any cloud architecture. So whatever we want to work with, we can do that from within. So I was trying to see what I saw. There was a couple of comments coming in. I wanted to see if great. Burgers are always great. Yes, indeed, they are. I'm hoping that that's the offer still on the table when I'm done with this call. So, yeah. So, so target kind of any cloud, any cloud architecture. So AWS, Azure, GCP, Kubernetes, Cloudflare, kind of any cloud you want to target. Obviously, these modern workloads are also tend to be very heterogeneous. We're working with maybe one primary cloud, but then lots of other pieces that make up our overall cloud infrastructure, and want to be able to work in a consistent way across those. Probably the most obvious thing, which we'll see as I kind of get into some demos and things, is that Pulumi embraces, instead of sort of a custom DSL or YAML dialect or something like that, embraces just using programming languages. And so using existing programming languages like JavaScript or Python or Go or .NET, the existing tooling ecosystems around them, to sort of bring a lot of these software engineering capabilities into the infrastructure space. And then finally, kind of one of the key things that we spend a lot of time thinking about is, how do we kind of bring infrastructure teams and development teams closer together? And we see a lot of organizations trying to kind of do that, both just the traditional kind of DevOps meld there, but really even more so, we see a lot of infrastructure teams that are moving to be kind of more software engineering centric. They're wanting more of the tools, they're wanting more of the sort of software engineering capabilities. And so you're seeing people with software engineering backgrounds coming and kind of doing some of that work. And at the same time, development teams, which are starting to own more and more of their cloud infrastructure. And so they're maybe a traditional application development or service development team, but they now need to know how to manage and work with a lot of cloud infrastructure. And so kind of on both sides of that equation, we see Pulumi playing a great role, helping application developers to embrace the cloud and helping cloud teams to embrace software engineering practices. And effectively, everything I'm going to show today is sort of open source. So Pulumi is an open source offering. And we do have a SaaS, though, for teams. And I'll maybe touch on that a little bit. That helps teams, enterprises sort of collaborate together if they're using Pulumi to deploy their infrastructure. So one thing I'll note briefly, and I'll kind of highlight this a little bit in the demos, but just because it's something that often comes up, one of the things when people see the idea that Pulumi is using kind of programming languages like Python or Go or .NET, they often think, oh, well, that means this is imperative. So isn't this just the same as me using the Azure SDK, for example, from those languages? And isn't this just something where I'm going to, say, put this thing here and delete this thing there and that kind of thing? And they might contrast that with, the traditional IAC offerings they might use, like CloudFormation or Terraform or something, where those are declarative, maybe those are desired state. And one of the key things is that with Pulumi, we're really trying to have the best of both worlds here. So Pulumi is still a desired state model. It's still describing the state we want our infrastructure to be in. It's just that the way that we describe that state is via writing a program that builds up that desired state. So the result of running the program will be that graph of what the desired state is of things we want to have. And then we'll go and make that desired state happen. And so that's something to keep in mind as we see the examples here. Everything that we're doing is still declarative, but we get to write an imperative program to build that up. And that allows us to sort of get all the reliability and sort of capabilities of a traditional infrastructure as code tool, but also the benefits of expressiveness and abstraction and productivity. So with that, I will spend a decent amount of time here just doing some demos and kind of walking through kind of how Pulumi works and what it feels like. And I'll start, maybe to start from kind of an empty slate here, just to give you a feel for Pulumi. If my fonts and things are too small, do let me know. I think this should be generally readable, but let me know if anyone needs me to bump it up. Okay, so what I'm going to do is start here. I just have my IDE open, and so kind of one of the benefits of me working in an existing programming language here is I get to bring all this IDE tooling. So I could say something like, let's start with the simplest possible thing. I'm just going to create a bucket. Right? So I'm going to say const bucket equals new AWS .s3. And one of the things you'll notice immediately is, we get IntelliSense, right? So we get, everything in AWS, right? This is all the different capabilities in AWS, like S3 or EC2 or IAM, everything you can imagine. And then within S3, all the different features that are available in here. So we got buckets, but we also got bucket objects and access points and bucket notifications, and every capability of the platform. And because I'm in an IDE again, I get sort of help text right in line, right? So now I'm getting all the information I need to know about how to use a bucket, for example, is right in line here. I'm going to get all that help text. And so all these little things that kind of help me out with working. So I'll just say I'm going to create a bucket. And now I'm going to say I want to have an export. And so this is going to be something that I can use from outside my Pulumi program. And so I said bucket name equals bucket.id. Okay, so I've written my first Pulumi program here. And what I'm going to do is I'm just going to come in here and say Pulumi up. And Pulumi up deploys the code that I've got in my folder right here into the cloud. And so the first thing you notice is that Pulumi up gives me a preview. And this is something that's fairly standard for infrastructure as code tools. We're able to understand what the desired state is. Oh, my credentials may have timed out here. Let me see. Oh, no, there we go. Okay. So the preview will tell me what's going to happen. So before I actually, this is part of it not being imperative, before I actually deploy this infrastructure, I get to understand what changes is it going to make. And it's going to do exactly what I expect. It's going to create this bucket. I can get the details if I want to see exactly what's going to change. It fills in a few of the defaults there. I can say yes, and this will go ahead and deploy that. Okay. Okay, so it took a few seconds and reported that the bucket name was, this bucket, and we added a unique ID here so that we can have this thing be unique. The logical ID of this is bucket, and the physical ID is going to be this. So this is now a bucket up in AWS. Okay, so now we can create some more objects, and I'll just do that more resources in the cloud. So I'll just do that to show kind of what some of the life cycle for these things looks like. So I'm going to create an object now, and I'll just call it obj. And this one has a few properties, and so I can see what some of these are, and I can see which ones are required. So like this bucket one is required, but the ACL is not. So let me provide bucket, provide key, and I'll call it obj. Provide content, and I'll say hello world. I think that probably is all I need. And so now if I say Pulumi up at this point, we'll actually understand what is the diff, what is the delta that we've applied here. And so before we had just a bucket, now we have a bucket and an object. And so we'll see that this is going to say I'm going to create just a bucket object, and there's two unchanged resources. So the overall stack and the bucket. And so you see that only what we need to change in the cloud needs to be run again. And this is that key infrastructure as code aspect. And again, we can see exactly what we're going to deploy there. Okay, so far this is really just traditional infrastructure as code. We could have been writing this in YAML or in HCL or in anything that we might want. But let's see what it looks like to do some slightly more interesting things. So because we're in code, we can do like a for loop, right? So we can say for const file name. So we can get the folder here. So now we've gotten, we're using the, in this case, we're using the Node.js libraries because we're in JavaScript, but if we're in some other language, we could just use their libraries as well. And we're just going to say, hey, my desired state is actually going to be figured out by me reading some files off of disk, which are going to tell me what objects I want to have in the cloud. And so I'm going to read this directory. I'm going to get all the file names out of the directory. And instead of me hard coding this file name to be obj, I'll just change these two to be file name. And instead of me having the content be this, I'll just read the content off of disk. So I'll read file sync, and then I'll just compute the file name. So I'll grab /files and add it to file name. Okay, so there we go. So I've changed this to be a bit more general and to have a for loop in it to upload all these objects. Now, one thing you'll notice as well, I mean, this is another benefit of me being kind of in this system is I get a little squiggle here, right? So I get an error telling me there's a problem with your code. And so instead of me having to wait until I deploy this out into the cloud, I can actually find out about that error right now. And in this case, it's just a little Node.js thing that I need to come over here and say like toString UTF-8 to convert that buffer into a string. But in general, this could help me identify other problems I might have with my infrastructure. So now I'll do a Pulumi up again. Let's make a few changes. So now I won't have that obj anymore. So it's going to delete that obj, and it's going to create instead these two files. Because if I look over here, I have in my I have these two files inside my files folder, right? So now I've got a different desired state. So it's going to delete one resource and create two others. And go ahead and say yes, and I'll just deploy those out into the cloud. Okay, so I'll just let that happen. And while that's going, I'll just show one kind of final thing I can do here. So what I can do is I can sort of take this function, this code here, and one of the other things we can do sort of in a programming language like this is we can kind of create abstractions, right? So one of the things we do all the time when we're sort of programming in a traditional piece of software is we say, hey, this is a pattern. What I want to do is give that a name, right? And so I can sort of say I want to write a function like syncdir, and I'm going to take in a bucket. So I'll let this work with any bucket. And maybe I'll take a directory. So this will be a string. Now we can come down here and just say, hey, I'm going to syncdir, and I'll just take my bucket that I created above, and I'll take /files. So instead of me hard coding this, let me just replace it with dir. Oh, there we go. Okay, so there we go. I made the last change, but now I've created this function. And so now I could take this function, I could put a comment on it to describe what it does. I could maybe store it in a package and push that up to a package manager. All the sort of things I can do with software, I can do with this reusable component here. But if I go ahead and run my program, we'll actually see that change actually didn't cause any changes to my infrastructure. Like I was just refactoring, right? I refactored my code to be a little bit more general purpose, to be a little bit more reusable. But it just says for unchanged. So I didn't have to make any changes to my actual infrastructure that I had deployed because of that. Okay, so there we go. So that's a very simple introduction, just using some raw building blocks. This, of course, may not be particularly realistic, right? This is not, when you think about the infrastructure that you manage, you're not talking about just a bucket and an object, right? You're talking about VPCs and networks and Kubernetes clusters and all these sorts of things. And so, but this shows you maybe some of those building blocks of how Pulumi works, how some of these infrastructure as code pieces fit in when you're working with real programming languages. So to kind of generalize this into some of the more interesting examples, let me jump into something a fair bit more complex, but that kind of builds on the exact same building blocks that we just looked at. And so in this case, what we're going to do is work with two things. We're going to kind of work with EKS, the Kubernetes service inside AWS. And we're actually going to work with Kubernetes itself. So we're just deploying Kubernetes resources. And if you're not familiar with either of those, don't worry too much. The ideas are fairly sort of general here. But for those of you who are familiar, some of these concepts may be familiar to you. So the first thing is, just like in the last example, we created our own little abstraction. So we created this function called syncdir, and it actually created several resources, right? When we called that function, it would go off and create, however many bucket objects there were in that folder. And so similarly here, this is using a higher level component called an AWS X VPC. And this is a library we provide, but anyone in the Pulumi ecosystem can also build their own reusable components and infrastructure. And this component, when I created, it actually creates a best practices VPC in AWS. So instead of me having to manually create all the different pieces of my networking infrastructure, like my subnets and route tables and all this sort of thing, I can just say I want a VPC. I want the number of availability zones to be 2. I can there's some other properties I can provide to sort of customize it. But the defaults are, it makes it really easy to create the sort of 3 or 4 most common patterns of how a VPC gets laid out. And so that one line of code will actually turn into quite a lot of resources. And let me actually just show you that. Actually, this is the wrong example. Let me pop over here. Just before I talk about the rest of this, let me just show kind of what the preview looks like if I go to deploy this. So unlike in the previous example where it was 1 or 2 resources, this example, even though it's only about, it's only like 100 lines of code or 80 lines of code or something, we'll actually see that it's going to create quite a lot of resources. So I'll give it a second to show the full preview. So there we go. Yeah, so we're going to create quite a lot of resources here. And the key thing is, if you look at this, we've got this VPC here that we described. And you see how it has all these children, right? So it has 2 private subnets, 2 public subnets, route tables, and for each one of those things, a NAT gateway, all different pieces we need to build this up. But I was able to create that without me having to go rewrite all that stuff or import, copy paste all that code into my application and take ownership of it. I'm actually able to just use a library like I would if I was kind of building some piece of software where I would use some reusable component that provided me these capabilities. Similarly, for standing up an EKS cluster, we have a high-level component that lets you stand up clusters in AWS, Kubernetes clusters in AWS. And this, for those who have done this, this is actually a fairly difficult thing to do, man, yourself, right? Even though there is sort of a cluster resource in AWS, you kind of have to stand that up and then stand up some Kubernetes resources inside that, and then make some changes to your infrastructure, and then make some more changes to your Kubernetes resources. It's quite a sort of subtle dance to kind of coordinate all those things. We can just take all of that dance, all that complexity, kind of put it into this component. Now you can work with this higher level EKS cluster. It makes it very easy, again, with just a few parameters to stand up a best practices Kubernetes cluster inside AWS. So all that is just kind of making it simpler to do the typical patterns you might do in AWS. But the other thing that's really notable here is that as well as providing access to AWS, we know that developers building a lot of these modern architectures are working with many different cloud providers, in particular, often working with a cloud provider and with Kubernetes. And so Pulumi provides kind of the access to the full Kubernetes API as well as the full AWS API. And so here, I have kates.core.v1.namespace, but you can actually see kind of everything you might expect there. So kates.apps.v1, every version of every namespace, and all of the different, Kubernetes resource model things that we would want to use. And so again, instead of me using yet another tool for this, like, maybe I'm using Helm or maybe I'm using Kubernetes YAML or something, I can just do that within Pulumi as well. And so now I have one pane of glass for kind of coordinating all these things. And it works really the same. I can create a namespace object. I can create a deployment that has my container in it. So in this case, I'm going to run an Nginx container. And it can create a service that's going to expose that out on port 80. But the interesting thing about this is that this one Pulumi deployment actually stands up the network, the cluster, and the workload that's going to run my application in that cluster. And so by deploying this one stack, these 62 resources here, I'll actually stand up from scratch that entire system and have that running and exposing an application on a publicly accessible port. And so this sort of gives me the ability to sort of really think about my entire applications infrastructure, not just the networking stack, not just the cluster, not just the workload, but the whole thing as a single unit of deployment if I want to. So That's just, I won't take the time to actually deploy this one because Kubernetes, the EKS does take a few minutes to deploy. But I'll just leave it there as an example of kind of what a larger application of Kubernetes focused one does. The last example I want to share is something that's kind of a bit more unusual in a sense. Like I think for folks coming from an infrastructure as code, you know, if you have familiar with other infrastructure as code tools, this one will look a lot less familiar. You know, the ones I've shown so far, maybe you can kind of say, hey, I kind of know how I do that in some of my existing tools. But this one's sort of more focused on kind of serverless use cases. So kind of talked about Kubernetes and containers. This one's sort of on the serverless end of the spectrum. And so one of the things we often see with kind of serverless architectures in particular, but really a lot of modern cloud architectures, is that folks, if you ask someone to go on a whiteboard and describe their cloud infrastructure, they're able to pretty quickly kind of go and draw out, you know, what the core pieces of their cloud infrastructure is and describe, you know, how it's all stitched together. And so one thing I might draw as an example like this, and I might say, well, my application's architecture is building an app that's going to, when a new video is uploaded to a bucket, it's going to extract a thumbnail of that video and put it back into another bucket. And so it's going to work by taking a video file, putting that in a bucket. That's going to trigger a Lambda to run when there's a new MP4 file. That Lambda is going to run some long-running FFmpeg task to do a keyframe extraction to pull out a thumbnail. And it's going to ultimately write a JPEG back at some point into a bucket, and which is going to fire another Lambda, which is going to tell me that it's done. Okay, so I can describe that in a sentence or so. But you might, you know, if you've done this sort of thing before, you might know that, hey, actually going and implementing this in AWS is not easy, right? And in fact, you know, this example came from an article that we saw early on when we started working on Pulumi that sort of took this specific example and showed how to do it. And it was, I think it was 40 pages to describe this scenario and how to kind of implement this. And it would use not just 40 pages of pros and things, but it used 3 different sort of templating languages, you know, another application code base. I mean, it was a whole bunch of different things you kind of had to bring to bear to make this happen. And so let me show you kind of like how we think about this from kind of a Pulumi perspective and how some of the infrastructure as code pieces that are unique to Pulumi can kind of help make this simpler. So I'll start by hiding a couple of details and then I'll walk through those in a second. But the core of this is really this program here. And so, you know, 70-ish lines of code to describe this. And just, you know, you can kind of squint and see that each of the top level declarations here is sort of one-to-one with one of those blocks on the diagram, right? So I'm doing something that's really one-to-one with the level of complexity of the diagram I use to describe this. And so what I'll actually do is while I'm going to describe this, I'll actually just see if I can deploy this. It should take, you know, 3 minutes or so to deploy. And so by the time I'm done talking through it, maybe we'll have something running here that actually represents this. So I'll let this run. This also deploys quite a few resources. So it's going to deploy 38 resources. And so I'll just let that go. Okay, so let me talk about what some of the pieces look like in here. So first, you know, we're just going to get our default cluster. So we're just going to use whatever cluster we already have in AWS. We're going to create a bucket, just like we saw in that first example. And then we're going to create a Fargate task definition. And so for folks who haven't worked with Fargate, it's just the ability to run a sort of a serverless containers offering, the ability to run a container just in the cloud without me having to worry about kind of an orchestrator or anything like that. In this case, what I'm going to do is just provide a few pieces of specification. I'm going to describe what image to run and how much memory to use. And that's going to be all I need to kind of run this. Now, to describe what image I want to use, I actually do something slightly interesting here, right? So what I'm saying is I want to actually create an image from the code that is in this folder. So I said from this /docker ffmpeg thumb. And that's this folder right here that has a Docker file. And right now it just has a Docker file, and that Docker file just does some bash and ffmpeg stuff. But this could be my whole application. This could be my Java app, or whatever it is I want to run as part of this long-running compute. And from the perspective of the Pulumi code, it's just saying, hey, whatever's there, go and build that Docker image. This is actually going to do a whole bunch of things, right? This is going to run Docker locally to do a Docker build. It's going to create a registry in AWS. It's going to push that Docker image to the registry. It's going to grab the image name from that registry, and it's going to use that as the image name for this task. And then it's going to give me a Fargate task that I can use to run instances of that thing. And so again, all with just a little bit of code, I'm able to sort of logically, the thing I care about is just I've got this code and I want it to be running in the cloud. And so I can kind of make that happen without having to worry about all the details of all those bits and bytes. If I do want to worry about those details, I can go and open code the low level pieces. But if I don't, I can just use them directly like this. Okay, so now I've got a Fargate task that can run my keyframe extraction. But now I have a couple of functions here. And so what I can say is I want to say this bucket that I created, I want to actually run some code if something happens. And so in this case, I want to run some code when an object is created and if that object is an MP4. And so what this onObject created does is it takes a Lambda callback function. And so that's going to be a Lambda that describes what happens when an object is created. And so it does two things. It sort of describes the policies that are available to that Lambda. So I give it some access to execute things. And then I provide a callback. And this is probably the most unusual part of this example is that if I want to, I can actually provide the code to run just in line here. So I actually wrote just a JavaScript function and said, I want to run this code when this object is created. And so I'm going to actually run this code that takes some bucket args, iterates over them, and then runs this ffmpeg task for each one. And so this, I could have done this by just saying, hey, I want to build the code at this location on my disk, or I want to take this zip file out of S3 or whatever I want. I could provide this code in a lot of ways, but for a lot of Lambda functions, they're just little simple pieces of code that lives in versions along with my infrastructure. They're just pieces of that glue logic, pieces of those arrows that exist in that diagram I showed at the beginning. And so we often we don't want to have to write a whole nother code base and manage it entirely separately. We want to just say, hey, I'm going to run this little piece of code here in line. And so in this case, we did that and we just write some code here. The interesting thing, of course, is that this is going to run. This isn't going to run when I deploy my application. This is going to run when someone puts an MPEG file in S3. And then similarly, I'm going to say bucket on object created a new thumbnail. This is going to fire when a JPEG is added, which is what that Fargate task is going to do. And again, it's really just going to log out which thumbnail files were added. Okay, so that's sort of a description of a serverless workload that sort of mixes and matches a bit of the infrastructure side and the application side, which is something that I think we see a lot with serverless workloads. And that really gives you one way to kind of deploy both of those things. And that deploy, we took about 3 minutes. We have this bucket here. And so, we could go and now put some, I think we have an example of grabbing one of these. So I'll just dump a file into the S3 bucket. And now we can actually run Pulumi logs -f to kind of see some of the logs that come out of this. And we should see in just a second that Lambda fires and starts telling us, oops. Yeah, there we go. So some of this logging that we see here is the logging that we did right in here on the video called. All right, so there we go. So we built like a little application there, just a handful of lines of code to kind of build a full serverless application that's kind of that whiteboarded thing and turn that into infrastructure. And this is sort of speaking to how do we enable application developers to kind of work with infrastructure more easily. Oops, didn't mean to stop sharing there. Okay, let me jump back to slides, just do a couple more, and then can kind of open it up to talk about any questions folks have. So one of the things I kind of touched on a little bit there was one of the themes around sort of unifying kind of dev and ops. And one of those is sort of bringing together a lot of these tools that we have to work with various different pieces of infrastructure that kind of lead to siloing the way that we work and lead to creating lines of ownership within teams that are sometimes not ideal. And so today, a typical DevOps team may have sort of the Terraform island, the Kubernetes Helm and YAML island, the serverless framework island, a bunch of bash scripts to sort of stitch things together. And one of the key things with something like Pulumi is that we can kind of move all of those into one model, one reliable declarative infrastructure as code kind of model for describing the desired state of our infrastructure and application logic in one place. And so we sort of see modern infrastructure as code as being about bringing these things together, having this unified model, and really being able to work seamlessly across these and have that ownership of that whole continuum be something that's shared across sort of the application development teams and kind of core infrastructure teams. For Pulumi in particular, I think Pulumi plugs into a whole bunch of different kind of ecosystems. I focused a lot here on kind of the TypeScript side and on the AWS side. But Pulumi kind of works with a variety of things from wherever your source control lives to a variety of different languages, including JavaScript, TypeScript, Python, Go, and .NET. A wide variety of CI/CD platforms that we might want to actually use to drive our Pulumi deployments. Instead of, in these examples, I drove them from my CLI and on my local machine, which makes sense while I'm in development. But obviously, when I move this into a long-lived deployment like a production environment, I'm going to want to push that in CI, and Pulumi can be plugged into a wide variety of CI environments. And then, kind of most importantly of all, providing access to a wide variety of different cloud providers. And so, all of these, and I think there's 50 or 60 more cloud providers that the Pulumi provides support for. As I talked about at the beginning, as well as all of the sort of CLI and open source SDKs and pieces that we have, Pulumi does also offer kind of a service. So with the state of my deployments that describes where that desired state is, by default, Pulumi will manage that for you in a backend service that has free tier available for individuals, and then has the ability to kind of use that with teams and enterprises. You can manage that yourself if you want. If you want to store it locally on disk or store it in S3 or Azure Blob Storage, you can. But if you choose to store that in the Pulumi service, then you get a whole bunch of other kind of capabilities, like the ability to kind of hook into GitHub and have rich pull request sort of messages, the ability to understand all the resources you have under management within these stacks and deep link into them in your cloud providers, and to get sort of a full history and audit logs of the deployments that you've done into your cloud infrastructure across all these platforms. And then just brief highlight, kind of all the stuff that we're talking about here is being used by a lot of, large and kind of sort of modern cloud organizations, folks like Mercedes-Benz Research and Development and Snowflake, kind of in the US, have been using Pulumi heavily as part of their kind of cloud initiatives. And then, have several customers here in Australia as well. One of our early customers who's done a bunch of really great stuff with us is a company named VGW that's out in Perth primarily, but several customers as well in the Australia region. And then with that, we have, as I mentioned at the beginning, I'm here in Melbourne, and so we're doing a few more events in the next, next month or so. And so if folks are interested in kind of learning more about Pulumi specifically and getting a little bit more hands-on with it, we do have some additional events. On March 24th, we have a workshop we'll be doing that just is a great chance to kind of go through and hands-on work through sort of some of the stuff we talked about today. And then we're doing a webinar along with the Octopus Deploy folks on 7th of April, where we'll show kind of a combination of both Octopus and Pulumi and kind of how to bring those together to sort of build that end-to-end CI/CD pipeline around your infrastructure deployments. And so if folks are interested, feel free to join us for those. And of course, we also have, you can find me on Twitter or GitHub. Slack.pulumi.com is a great place to go to get to join the Pulumi community. So with that, I'll just say thank you to everyone for joining, and feel free to ask any questions that folks have, or reach out to me, Luke at Pulumi.com. Thanks again.